Welcome to the GOTO Podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
So what we are going to say is microservices. You're both giving talks about microservices. From perhaps an optimistic and a pessimistic perspective, perhaps, we'll get into that. But I think one of the nice things about talking about microservices now is we are at least 2 hype cycles down, right? It's no longer cool, it's no longer hip, and we can talk about what it actually is and whether it worked. So let's just start with the big picture. Ian, was it a good idea?
So yeah, when I give talks about where did it all go wrong, I've got another one about TDD. It's meant in a very loving fashion. So there's a famous story of George Best, who was in his hotel room with a Miss World lying next to him naked, with champagne and cocaine around the room, and a bellboy brings in basically the some more champagne and some caviar. Looks at him and goes, George, where did it all go wrong? And so it's meant in that context that I think in some cases I look at where people think a practice has broken down, why and what has led to that viewpoint. So I think of late there's been a bit of press saying, microservices are all a disaster. Amazon can't figure them out. No one. There's a whole Prime Video episode. Why are we at this point? Is the question I kind of wanted to kind of get to, and I think I don't want to necessarily jump over James, so I will surrender the floor in a tiny bit when I introduced it. I think the problem is occasionally, like a lot of things in tech. People take what is a relatively straightforward set of ideas, rules, and principles, and things get confused, right? Things get confused as we go forward. There are misunderstandings around key terms. So micro, unfortunately, is a bit of a thing that caused, in my opinion, some misunderstanding, right? Even though in the original paper, it tends to be quite clear about what it actually means. And I think some of these in the DevOps community and the simultaneous arrival of containers and Kubernetes also caused another set of misunderstandings. And I think the other thing is when you get into practice of this monolith to microservices journey, there are decisions people quite often make because they're doing it at speed. And when people, because often the thing that causes people to want to use microservices is that they need to scale their organization rapidly. They need to bring many more developers to bear on the problem space because they have some kind of scale up and they are growing at velocity. And the problem with that is that that's often the worst time to be making decisions about how you partition your software and how that software interoperates because it's all done at pace. And I think part of the problem is there's a first generation of those decisions which people look back on and regret. But I think that actually they've learned a lot about how they should improve it. For now, they've gone beyond scale up to be much more a kind of stable state, and they can look again at that infrastructure and go, you know what, we learned a lot, and maybe we should redraw the boundaries a different way. But I don't think that always comes over in the discussion about microservices. I think what you get a lot of it's all been a terrible mess, and that's the choices you made have led you there. But it doesn't mean you need to abandon microservices. It just means, okay, we've learned, we'll apply those lessons to how we move forward with this. But yeah, I think a lot of it is that misunderstandings and often application at pace.
Yeah. The thing I want to pick up there is boundaries, because it's terribly hard to know where to draw the boundary lines around services or microservices or bits of the monolith that live in different libraries. You're a Thoughtworks person. You can answer that. Tell me where to draw the boundaries.
Right. So what you need to do is you need to get a pen and you need to write all the things on it, and then you draw around it, and that's your boundary. It's fine.
Easy as that.
Yeah, easy as that.
How much do you charge for that advice?
Oh, I don't know. You can't afford me though. But it's interesting. I mean, like, I think you said something fascinating there about Prime Video, for example. If you came across this thing where, hey, we're moving away from microservices, we're going to refactor everything into this new into this model. They didn't at all. They actually refactored a bunch of functions into a microservice. So it wasn't. It was completely miscommunicated, actually, in a way. I mean, I actually. I agree, actually, with everything you just said. This is going to be a terrible panel because we're just going to agree the whole time. I agree with everything you said. You know, there's a generation of organisations that adopted it early who are now hitting the boundaries, I think, and finding new problems actually. But also, there's I think a misunderstanding somewhere along the lines. I did a talk several years ago now, maybe 2017 or 2018, called "Building Software That's Never Done." And one of the core principles, one of the ideas behind microservices is, and the shift to products versus projects. You know, the project thinking was about getting finance for a thing that's then finished, and you're done, right? So you decide decide the boundaries, and then we're going to build the thing to the boundaries, and we go, oh, we've got the boundaries wrong. Damn, microservices suck. Well, actually, the whole point of it was that you were supposed to be able to morph these things. You were supposed to work in teams that were able to make their own choices about where those boundaries were, and if they were wrong, you should be then going on to change those boundaries without having to get another project-based funding for that, because you're funding as a product team over a longer period of time. There is another question, I think, related to that, which is, well, I think this is fascinating. Were they a zero interest rate phenomena, right? And actually, is product thinking and product team thinking a zero interest rate phenomena, where we were talking about scale-ups, we were talking about, whereas at the moment everyone's talking about cost efficiency and economies of scale. I think that's a different question as whether product continuous funding versus project, short-term funding.
You're not talking about technical debt interest. You're talking about because money was so cheap, we could do all these crazy scale.
Yeah, we'd hire 1,000 developers, and we'd have these 1,000 developers do the thing, and as long as we were making money hand over fist, then that's fine, right? Whereas actually now, what I'm seeing in the market is a retrenchment away from that, back towards this idea of what we'll have much smaller teams.
So there's an idea continuously you could grow your way out of the problem.
Yeah.
Whatever the problem was, it didn't matter because you had 20% growth and you'd basically have the capacity to solve the problem with just more people, right? Yeah. And that was, I can remember having conversations with, staff engineers in my team who would say to me, Ian, no one seems to care that this is incredibly inefficient. And I said, you're right, they don't. And that's not going to be an argument that you're going to win with them because they're just going to go, well, it's all right, we'll grow out of it next year. I think the other thing that's interesting, I kind of want to bring, I'm only going to touch on it a little bit when I talk on Thursday, is, so there's this problem, effectively, which is the continuous thing you mentioned, which is, what we do as software is we build a thing with a structure. And the problem is, we create that structure based on a moment in time. And that'd be great if the business we worked for never changed. Of course, the business keeps changing and evolving and having new ideas, etc. And so then we define there's complete misalignment then suddenly between what the business does and our structure, which is what we tend to think about as technical debt, right? And that is just domain-driven design has this type of context mapping, which is this kind of way of trying to say what is the actual domain now compared to what I'd actually build, and oh my gosh, everything seems to be misaligned. So one of the things I think in case people miss about microservices is where did this idea of small come from? I don't think small was the focus, but replaceability was the focus. Was this idea that we're going to need to keep evolving because the business is going to keep changing, and the only way to basically solve that problem is to change our software, right? And changing our software has proven to be hard when we're inside a monolith because we just get entangled into a ball of mud. So is there a technique which makes change easier to cope with? So I think I partially agree with you on zero interest rate, but I wonder actually if it's more businesses are changing less that is actually causing the phenomenon,
or rather that that group of scale-ups and hyperscalers have turned into more mature organisations and are slowing down a bit. That's a very interesting point. I mean, I think looking at one of the original inspirations going back about 2005, 2006, 2007, I worked in investment banks a lot, in front office, sitting on trading desks with traders, building software. I don't know if you've worked in those environments, but they're incredibly fast-paced. The idea that you can say, put that feature request in my backlog, I'll get to it in 3 months, because I've got this big monolith and it's really hard to change, and we've got loads of other requests. That just isn't going to cut it, because you need to take advantage of an opportunity in 3 days. We need to start trading this new exotic in 3 days. Can we do it or not?
I wish I'd had that experience, but go on.
Oh, right, okay, right. When you were trading, okay, fine. So I can name them. So I was at Citigroup, I was at RBS, and I was at Dresdner Kleinwort as well. In capital markets, equities, and interest rate derivatives.
I'm not going to name the banks I've worked for, but my experience was everything would take 18 months unless it was a regulator requirement, in which case you just move heaven, earth, and hell.
Right.
Because you had no choice.
And that does happen as well, often with the middle and back office, more middle and back office systems. But sitting with traders, where they can we do this in 3 days? I want to be able to start trading on this with this product on this product in 3 days. You need to be able to say yes or no, based on those sorts of timescales. And the way you could do that was by building small bits of software that did individual small bits of things. So you wouldn't take the big, so you've got a fire hose feed of pricing information coming in from Bloomberg and other places, right? So you wouldn't take the thing that's publishing the prices that you've already got and change that to add the new things that you need and deploy that again. You would build another one, maybe you can copy and paste that thing, and just change the internal so it was the new thing. And so doing that, you ended up with this estate of lots of these small applications doing small things. So that was again one of the and that was absolute pace of change.
Yeah.
So one of the things that I do talk about, I'll be very quick, in my talk is, back in 1975, you ordered effectively such a down and structured design. There's a little graph, right, and it talks about what we call intra-module, inside the module dependencies. And it says, of course, the smaller you get, the more you reduce the intra-module dependencies, so the lower coupling you have. But the more services you have, the more you increase the inter-module dependencies. So you get a curve a bit like this, right? So I refer to this as the Goldilocks point. There's a point for your business where effectively you have maximized, you've got as small as you can without increasing the number of services to the point that, but that's different for everybody. Unfortunately, there isn't like someone can say to you that number's always 42. Once you get beyond 42, microservices is a disaster. The difficulty is you have to find that number. Everyone is obviously going to get that wrong, and then have to try and adjust. Now I've got a better clue for my business what that number is, and of course as your business changes, that point may change. But that's what you're trying to do: hit that point where that balance between getting smaller but having too many things that you're then replacing it with dependencies between things is right. And that's been true since 1975.
Yeah. But that connects back to the idea that we're now 2 hype cycles down at least, right? Have we learnt anything about finding that number? Have we got any wiser about going into a new project with microservices?
So again, maybe I'll answer that question by answering a different one, which is always a good technique if you're a consultant or a politician, actually. So I think we've learned quite a lot about. I think yes, but sorry, I'll back up. My perspective on this is still and has always been that it's a particular architectural style that you should use if you've got a particular set of problems, right? If you've got the requirements that mean microservices make sense, then use microservices. It's the reason we've never had it on adopt on the Thoughtworks technology radar is because you can't say it's a sensible default architectural style, because it's got sharp edges. You're going to cut yourself with it unless you do a bunch of stuff. It's a bit like XP. If you just take one of the extreme programming practices and say, hey, we're going to be successful because we're doing on-site customer, right? But you forget about pairing, and you forget about test-driven development, and you forget about user stories, and you forget about all the other ones, right? Then you're not going to be successful. I think that's very much the same with microservices. You can't expect just because you've got lots of small things to be successful. You need to think about all the rest of it. Are they independently deployable, right? Do you have the infrastructure? Do you have the ability to manage them in production? Are you running build it, run it teams? Because that was the original idea, was that you'd actually be building these things and running them yourselves. So what have we learned? I think what I've learned is people still tend to make decisions based on the hype cycle, because hey, this is cool, right? And let's do that. In the same way, I think it's like the default these days is, hey, everyone must use Kubernetes, right? Everyone has to. If you're not using Kubernetes, you're not cool. Well, actually, you can run stuff on bare metal. It's fine, right? That's actually okay too. Do you have the requirements that necessitate or lead you towards microservices? One of the original talks I did, Java the Unix Way, was back in 2012. In QCon San Francisco. It's before Martin and I wrote the definition up. Was about I think it was called the subtitle was how we built an event-driven system based on services that are 1,000 lines of code each or something like that. And that was because we had a particular set of requirements. We needed really high throughput. We needed low latency. We needed to be able to burst overnight to do sort of auto-scaling stuff around convenient consumers and queuing. And we had these requirements that sort of pointed us down this direction of building the system in a certain way. And I think that's something that we maybe need to hold to a bit more than how many is the right number, right?
Right, yeah. That reminds me, thinking of banks, I'm going to throw this one at you, Ian. So I think one of the requirements that leads to needing microservices has never been technical. It's always been organizational. You hit the point where your biggest problem is, in order to release something, you need 2 other departments to coordinate with you. And those are the projects that fail or slip behind by 6 months. Are microservices really a technical organization, or are they a social organization turned into a technical problem?
Well, I think microservices and organizations go hand in hand, right? Because once you adopt microservices, I think you enhance the impact of Conway's law a bit, right? Because you're effectively saying, I'm going to create a collection of people, process, and technology and use that to deliver a microservice. And one of the anti-patterns I've seen occasionally is, this team seems very busy, these people don't seem busy. We'll give them, basically, they can build a microservice. And actually, you probably shouldn't have broken those 2 things apart, because, for example, one of the forces that I would say means you shouldn't break things apart would be, needs to be an ACID transaction here, not a base level transaction. So as soon as you get that and you split their apart, they end up with this very chatty thing that it's not very reliable. And you did that because you decided to adopt your organizational solution to the problem, right? So I think the problem is, if you can't orient your organization around the delivery of microservices, you will struggle, because the 2 forces will keep continuously bashing against each other. And we also I also see turf wars about surely we own this responsibility and this microservice, and you can't own that bit, because people are human beings, right? In the end, it's always a socio-technical problem, as we say, right? And it's or Tom DeMarco, that it's always a people problem, right? And I think that it just becomes clearer with microservices, because you are orienting around groups of people delivering given things. You surface that problem. I suppose it exists in the monolith, but you bury it under the mound, whereas with microservices, it just becomes clearer that you need to solve socio-technical problems as well. I just want to go back on the partition thing and the question of, because it's the most fundamental problem for microservices, right? And or any architecture, what architects do, if you believe in that term, is partition software. So how do we partition software? And I don't want to abuse the idea, because I can give you a short version of it, it'll be bad. Which is the most interesting thing I've seen recently is Barry O'Reilly's residuality theory. So Barry decided that we don't really know what we do as architects.
And boy, does he tell everyone about it.
Yeah. He's the only architect that will admit it.
Right? He's very good. And what he's saying effectively is more, we have these kind of practices that we use, but none of them really... The answer is we just deploy them, but none of them are effectively successful. What's actually successful, we just have some intuition and experience, essentially, that we're applying to the problem. And we rationalize it by saying, oh, well, yes, I used domain-driven design to figure this out, and we probably didn't. We probably just then reapplied domain-driven design to justify the decision we'd already made. But he has an interesting take on how do you solve this problem of it's a chaotic world, and you're trying to build a structure for it. So his idea effectively is actually he's probably going to hate me, but an anti-fragility style approach, where effectively you create what we call a series of stresses that are effectively an arbitrary number of things that could happen. You take your naive architecture, you subject it to the stresses, you understand what that results in. Generally, the results tend to cluster as things that would happen to the system, and then you say, well, what's the fix? And then you buy those fixes depending on your business priorities. So it's a way of trying to simulate what might happen over 5 years, so that effectively, rather than having to experience those 5 years and go, wow, it turns out 2,000 microservices wasn't the best idea, that you could actually simulate that and prove to yourself beforehand, okay, that wouldn't work for us. Probably my simulation suggests we need about 30. And it's a very interesting idea that we could, rather than experience the pain, we actually simulate the pain, and as a result, at the end of that, go, okay, if you want to avoid this problem, we should do this right now, right? Or at some point, we're going to need to do this. You could defer that, but you're going to need to do that before you get to this point. And if you've not checked it out, it's very interesting. It's definitely, the only slight problem is Barry wants to basically teach people how to do architecture, and I think at the minute, the main audience for it is probably people who do architecture. So it needs to get slightly broader, but I think if you are struggling with that problem of how the hell do I, at this point, make decisions about how to partition my software in anything that's more reliable than that, it is definitely an interesting technique.
It definitely is. I mean, I've been, because it's founded in complexity science and chaos theory, actually. So when you talk about the way that a system could evolve, by applying these stresses, you identify the attractors, if you like, in a complex system. So, there are different, there tend to be different, even though you're applying different stresses to what you have, that there are these attractors, these clusters, or clusters of future states that are more likely depending on the.
Give me a concrete example.
Good. Oh, well, there's some really interesting ones in his talks. There's a great one about electric car chargers. You come across that one?
Yeah, I have seen electric car chargers one. Yeah, and what happens if somebody loses their key fob, right? So they say, okay, well, we'll put in, we'll just pay for it by effectively having number plate recognition. You'll drive up, and we'll just take it off your account. And it's interesting because later they raised the problem of what happens if somebody tries to steal basically our electricity. It's okay because that attractor where we recorded your number plate means we have your number plate, so we just, send you a big bill in the post.
And there was another one right with the meat.
Yeah.
There was something apparently that started happening. I think it was in Germany, but I'm not entirely sure, where some folks were getting quite upset with the idea of having to. The drive towards
EVs,
electric vehicles, and so these protesters were starting to stuff mincemeat into the chargers, and so this is an example of actually like a totally unintended thing, because when they were trying to work out how to stop this, it turns out they'd already solved the problem by having implemented the feature of number plate recognition and et cetera. So by solving a set of other problems, they'd solved for a wider set of problems, and that's essentially the attraction of the field.
So the idea is these attractor states are ones that effectively there's only a certain number of them. As you keep creating more scenarios, in theory, you don't create more of these attractors. So that gives you a feel for what could I build that would end up being a resilient system that would work for me. So it's definitely the most interesting way I've seen of trying to solve this problem in a long time, without the current solution, which is kind of try, experience pain, and adjust, which works. I mean, all animals basically work by that mechanism, but it's not the kindest way for us to figure out what boundaries look like, right?
Yeah, there's a proud tradition of fool around and find out, right?
Yeah, but there is, basically.
We could try something. So are you saying this is a technique for figuring out what your microservices boundaries would correctly be ahead of time?
I don't think correctly. I mean, it's similar to a set of practices that have already existed, right? So if you think about, right, we've got a current system as a state. It looks like this. We've got these boxes, and we've got these software systems. They communicate in this particular way. What should we do? How should we proceed? How should we migrate away from whether it's a legacy, pricing, whatever it is, right? Legacy software. I mean, what would I do in that circumstance? And often I'm asked in to help with these sort of questions. Is what I would think. I've come up with the current state, and then I would think about a number of future states, and then I would think about some pros and cons of each of those. Okay, what happens if I split things up into self-contained systems, say? What happens if we go full microservices? Or what happens if we just replace the monolith with another monolith because you're going to buy it from a supplier somewhere, or whatever it is? And then you try and understand what the risks are associated, the constraints, the pros and cons are of each of these things, and then you make a recommendation. That's generally my job, right? I'm a consultant. and then I'd walk away, and everyone else has to solve the problem. This is one of the guys who solves the problem, of course, because he does real work for a living as opposed to just wave his arms around. But the idea of residuality is putting structure, much more structure to that, and crucially, mathematical underpinning of it, such that these are, because you have these attractors, the attractors will mathematically, well, there's a mathematical relationship between the attractors and the number of states that the architecture can turn into, and the number of ways it can fail in the future.
Yeah.
So it's a sort of more scientific.
You can figure out. You have to get a big spreadsheet, but you can figure out by a big spreadsheet, are things when stresses happen, are things impacted together, or are things that basically are. So those things that are impacted together, you have to ask the question, okay, if a whole load of times these things always seem to be impacted together, a question would be, are they really part of the same thing? Should I really partition those, or are they always actually subject to the same forces of change? Yeah. Which is something we tend to say is, things inside a given any kind of module is things that are subject to the same forces of change. So it would say to you, these things subject to the same forces of change, and it might also say, this thing is actually subject to quite diverse forces of change, and then maybe you should break it apart, and that would actually make your architecture more resilient. So it does try to figure that out for you as well. So it's like anything. You're exactly right. It's formalizing which is Barry's intent. It's formalizing people who have been succeeding. He tried to figure out, how do they succeed? Okay, I can give you a proof of that, and I can give you a formal way of achieving that. You still have to, at the end of it, you do things like ATAM and Vermeer and go to the business and figure out what that architecture looks like, but at least it formalizes that stress part of the process without you having to experience it.
And one of the things I find interesting about it is, and we're just starting to see its use picking up now, and this is why I think we're both struggling somewhat to describe it, because it's still, I think, it's PhD.
Is it the next hype cycle?
It's the next hype cycle.
Awesome.
Yeah, absolutely.
You heard it here first.
I think his book is number 3 on Lean Pub at the moment, so it's getting the hype already.
Right.
But I think it's interesting for me, because one of the problems we've got when we're building software in teams of people in organizations is you can't solve for time, right? So, I mean, any decisions you make about the structure of the teams, the software that you're building, each line of code that you write, the impact of that is only going to be felt in the future. And the only way of knowing what the impact is to go to the future and find it, right? So simulations are, I mean, this is how you would solve for this in, for things like, I want to build a new wing for an aircraft. You don't just build the wing and then put it on an aeroplane and see if the aeroplane spirals down to crash. You simulate it, put in wind tunnels, you build mathematical models, you do all these things.
Yeah.
And I think there is an opportunity for us in the industry to do a bit more of that, actually. And because then you can run the simulation many times much, much quicker than it takes to experience it in 5 years, if you see what I mean.
You're going to have to make that more concrete for me, because it sounds like we should build some software that simulates the software we're going to build, and that sounds like another 18-month project before we even get started. Yeah,
well, I mean, I would start by building the simulation of the simulation of the simulation to build the simulator for the software that we're going to simulate.
But you build by the hour, so that will work for you.
Day. Come
on. But are we? How can you feasibly build a simulation of the system you're trying to build when software is inherently a simulation of the thing we're trying to solve in the real world?
Yes, you're simulating effectively how things change over time, right? So you're simulating how a structure reacts to forces over time. But honestly, I mean, you can do it with a spreadsheet pretty much. But I mean, if we were in complex financial modeling, we'd be running Monte Carlo simulations all the time. It would be bread and butter to us. That effectively, that's what you do. You say, what happens under all these variable conditions? What are the outcome, right? And so I think the question is, if we go back to the original point about microservice, which is there's effectively this kind of Goldilocks point, and the difficulty getting the Goldilocks point is, can I predict where effectively this balance comes from between intramodule and intermodule coupling? And the current best way we know of finding that is to suck it and see. The question is there a slightly less painful way of doing that? And maybe that, we could probably get closer. I kind of think, I suspect it probably will be a good approximation, but it's probably a better starting point to be there or close to there than it is right now, where the problem is it's skill and judgment, right?
Yeah.
And
I think based on, I mean, we talked about the U-curve earlier, so you've got this U-curve, right, which is, there's at some point in the middle, there's an optimum. You don't necessarily have to be at the optimum at that exact point. But there's a Goldilocks zone, I guess, if you use borrow the kind of distance of the Earth from the Sun, where water can exist as liquid water.
We've all worked for companies that are definitely not in the Goldilocks.
Right, yeah. Well, where have you been working? It's Mars, it's pretty cool. But no, anyway, so you have this U-curve, but the fact is you can be either side, right, by margin. What you don't want to be, because it's you don't want to be at the point where it suddenly shoots off into infinity, right?
Yeah.
So if there were better ways, I've described a technique I would use to try and identify where you are in that U-curve, and potentially this is another way of more accurately then.
Okay. Yeah.
Yeah, feeling out where basically that zone may be, what you might be trying to target, and so there's a better chance that you'll have a good landing, right?
Zeroing in on it early. Yeah, okay, I can see that. Then let me ask you if that model allows for something else that's always bothered me with microservices, which is, let's say you use this model and you get roughly at your correct boundaries, and everything's good. You always have concerns that cut across all boundaries. Like the first one is always auditing. You've got to see an entire holistic picture of the system, and that is always a requirement. Have either of you got any solutions for that while retaining your nice microservice boundaries?
I've got an example, which is the degenerate case, I guess, for that, which is an organisation where they have about 2,000 microservices, and it's a financial institution, and they decided that for audit reasons they were going to use the event log, each of the message logs that each of the microservices were producing, and the logs as well, and they were going to use that as the audit trail, which meant they've had to, for each of these microservices, which is producing how many megabytes of logs every hour or whatever it is, they have to keep those and archive them, and they've ended up with a login and audit infrastructure that is literally 2 orders of magnitude bigger than the actual production infrastructure that they're running the system on. It's absolutely astonishing. But that's an interesting decision that was made. You thought it was we got all this information, it's brilliant, we'll use that as the audit log. Oh wait, 2 years down the line, it's another one of those 2 years down the line. We didn't realise things. Yeah. I mean, I think there are ways of of not doing that. I mean, one example would be data mesh, which is I see data mesh as the sort of the last piece, if you like, in the sort of puzzle of how we are able to build independent, or systems that are independent from one another. Because obviously we've had data lakes, we've had enterprise data warehouses, we've had all these sort of things. They've all had similar sets of problems associated with change. If you change schemas here, you've got to change schemas there. If you're going to change all the ETL jobs, you're going to change all that sort of stuff.
Do you want to give your quick definition of data mesh?
Oh, it's going to be terrible. My former colleague Zhamak Dalgani wrote the book on data mesh. But the basic idea is that each of the domains that you're interested in essentially serves or advertises and serves its own data set. Data is a product, essentially. And so then if you want to compose, for example, reports from different places, or you want to do whatever you would do normally with a data warehouse, rather than go to one specific location, you have the ability to discover where that data is and then query that data from essentially source. I mean, that's kind of idea. Again, it's an organizational problem as much as anything. It's about the other teams building that software, offering those contracts up and blah 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 blah. So but that's an interesting way of solving for that, in a sense.
Can I ask a deliberately pointed question?
Yes.
Back in the old days, we just used to call that a database, and there'd be all the tables in the whole system, and we just look at those. Why is what you're describing better?
Well, so it's a question of scale, right? So say you're say you're an insurance company, right? You might be wanting to run queries that are across not just a particular system, which was previously represented in a single database schema. You might be wanting to create, because otherwise you wouldn't have enterprise data warehouses, right? Because you'd have an enterprise data warehouse which would be fed by all the different source systems that you've got in the organization. So you're not going to have one database ever. You're always going to have lots of databases feeding a single big thing, and then you're running reports on that or generating reports of that. So I fundamentally disagree with your assertion there. Sorry.
I'm just for the sake of those that I know some people will wonder about this, right? Why it can seem like we've split our system into many microservices, and now we're just trying to put it all back into one piece, right? We've correctly decoupled all our boundaries, and there aren't shared databases because that's one of the golden rules of microservices. So we now have 2,000 microservices with 2,000 databases, and we now find we need to query across the whole thing. So we invent the idea of data mesh to pretend it's all one big database again.
I think one of the things we learned is the difference between the needs of transactional and analytical data.
Yeah.
So, I mean, typically, say for us, in the transactional kind of data world, we can use at-scale databases like Dynamo, because generally what we need to do is store something with an identifier, maybe 2 identifiers, but it's just very easy. It's a key value lookup, right? So if I want to look at your shopping cart, or I want to look at your customer record, or where the restaurant currently is, which is my current place of work, very easy. Just look it up on a key value store, I can find that, right? But obviously, if I then want to basically slice and dice that data in new and interesting ways, I need a different kind of data store, right? So I need some kind of ability, potentially relational, or potentially other graph. I mean, all sorts of ways I might want to slice that data. So as soon as you get into that world of kind of polyglot views of your data, you kind of also begin to move away from this idea of I could have one single database that would serve all my needs. Now, the reality is, as James says, before people start doing the wrong thing at the wrong scales again, it is a scale problem, right? If essentially there are 40 people that use my system, sure, use a relational store and query it, right? Once you get basically the numbers begin to get bigger, and the way that you want, and you outgrow your relational data store. I mean, I think it's public knowledge, so I'm pretty sure I can mention about before my time in 2016. Just Eat famously sponsored X Factor, and during X Factor's kind of like Saturday evening break fell over because it was trying to build on a relational data store that effectively just could no longer cope. It was about the biggest, version of that data store they could get, and just no longer could cope. So that's a lot what drives you towards that kind of problem of I need to break things up, I need to have smaller stores, I need to use a kind of at-scale store like Dynamo because it's not cheap, right? But as soon as you do that, you're then right, okay, but now I've specialized my database to be able to cope with the kind of volume that I'm seeing. I now need more databases because they're all filling quite specialist niches in what I do. I think to also answer a question about sort of audit, etc. So we definitely see some of that in almost like a semi-mesh sense where things like we need to know where all the GDPR data is, right, across this thing if someone wants to cancel it. So we actually have things that the services tell another service, I have some GDPR data. So you can go to this central service and go, well, where is the GDPR data? And it tells you, okay, I can tell you who owns the GDPR data for this customer because they've all told me that they own some of it.
Example.
Yeah.
I've got a good so on the database thing to split them up. I was at an airline many years ago now, and they had one giant database that served everything essentially. So it did both the airside operations, so check-in and all the green screen stuff. They had green screen interface to it. It's a SQL Server database, but it also served on retail and flight availability and all that. So it did both sides, everything. And they had, I don't know if you remember, it was many years ago. The previous Icelandic volcano problem, which grounded loads of flights, and they ended up pretty much being grounded, even though they weren't flying routes through that went near the volcano. They were mainly flying south, and the reason was because people got worried about whether their flights were going to be cancelled. Hit the website en masse, like thundering herd problem, and of course it's because it was a single database. It started slowing down, and then this web page isn't loading. Refresh, even more load, and then the whole thing just fell over, and they ended up having to go back to pen and paper, boarding planes. It was a complete catastrophe, and that was literally around because they had this single database serving all the purposes.
So ultimately, your answer to that is we just can't go back.
Well, it's the HR problem, isn't it? Right, which is it depends, but I think the thing is, what is your context? How big? But that's the useful thing I think about residuality theory is it would tell you, okay, these are the states you move into. If these things happen, are these things going to happen? Well, maybe if we're successful in 2 years, that happens. Okay, then we'll come back and look at this and we'll figure out we'll buy all that complexity. But I think it's the age-old problem where So I mean, the reality of most big companies that I've worked for, right, where effectively is that we come to conferences and we talk about the exciting things that we're doing, but the reality is that's these teams that we're willing to talk about doing the nice exciting thing. We don't want to talk to you about the other teams who basically are in hell, right? And the problem is that people go to that conference and they take away, Uber's doing this or Microsoft's doing this and I must do this, right, effectively. But that area is quite often thought about that context and has said, we have this context to do this. There are whole parts of the business that are just doing nothing like that, right? And so that this notion quite often of context, I sometimes feel like talk should come with a health warning which says, this is my context. And if you have context like ours, the ideas I'm about to express may help you. If you don't have my context, I can't tell you, right?
There's a reason patterns come with context and forces, right?
Yeah.
Pattern languages.
It reminds me of exactly like one day, it seemed like one day Microsoft announced they were doing microservices, and every size of company now tries to do microservices.
Yeah. Right. Well, I think the problem is as soon as you, partially also, I think there's an industry problem, right? And the industry problem is that we don't hire people as software engineers. We hire people as a set of skills and keywords on a CV that gets fed into some recruitment machine algorithm that pops out the relevant CVs that match. So we incentivize people to basically have microservices on their CV or Kubernetes on their CV or Rust on their CV, right? Rather than saying, well, you're a software engineer, I guess probably, we give you the skills to solve problems and you solve the appropriate skills problems. And if it turns out there's a particular technology stack that you're lacking, well, we'll just teach you, right? It'd be a much better world. Unfortunately, people will always react to what you incentivize them for. So if you say, I'm going to pay you $20,000 more if you know the microservices, everyone's going to want to say, I'm going to do microservices at my current company so I can go to my next...
I was at a government department, which that shall remain nameless, and suddenly they had all this, everyone was a security architect. Because, also genuinely, everyone was just, because where are all the other ones? Well, they used to be these other architects, but now they're security architects. How did that? Well, they get paid $20,000 more because this pay scale, civil service pay scale, is more for security architects. So they all just went boom. Well, we're all security architects now.
The other really famous case of that is when .NET came out. They basically had, Visual Basic .NET and C# .NET, and effectively they both, because they were both trying to represent the underlying assembly a model in the runtime, were very, very similar. It was just like what's the difference of dialect, right? Yeah. But C# developers were paid like 20% more. So overnight, there were no more VB developers because everyone just said, well, it's pretty much the same language, so I don't just declare myself a C# developer. And then there's no more VB developers, right? I mean, but why wouldn't you do that, right?
It seems utterly predictable in hindsight, and it seems like we're not learning. So I'm going to ask, because we're at time, I'm going to ask you to leave me with the name of that book again, because it sounds like the one place we might learn to predict some patterns.
Residuality theory. It's Barry O'Reilly. And there's some great talks on YouTube if you want to start getting into the idea.
Cool. James, Ian, thank you very much.
You're welcome. Thank you.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.